Cool, let's get started then. So you have now all made your way to this obscure room in the middle of nowhere to watch a talk, hopefully on neo4j. If you're not looking for a neo4j talk, you did find a weird room, but you're in the wrong one. So we're going to have a look at neo4j, and it's mostly neo4j, but a bit of .NET stuff at the end. And yeah, my name is Klug. I work as a software developer / architect / public speaker / let's call me consultant at a company, which means I do anything I get paid for in the technical space, right? But I also go around to conferences and talk about different things that I enjoy doing. But most of my day work is at Active Solution in Stockholm, as such. And yes, I think I've had my MVP title for 15 years now, but that's got very little to do with most of the stuff that we're looking at today, because I have ventured outside of my comfort space of Microsoft and started looking at neo4j. And by started looking at me, we're building it into my current application on a bigger scale at the moment. And I found neo4j about a year ago, and we started playing with it to see what we could do with it. And it's interesting, because I have never worked with a graph database before. And neo4j was nice. It basically, my personal feeling is it is everything that I wish databases had been my entire life. It has everything that I need in a way that I want it, so it just makes sense. But let's go back and have a look at what does a graph database actually mean? What does it mean for us as developers when we think about structuring data? And instead of let's start here. How many of you are doing SQL-based workloads today? Okay. How many of you are doing graph-based workloads today? Or graph-based databases? None. Okay. So most of us are comfortable with SQL, because that's kind of where, as a .NET developer, if you're in the Microsoft space and you need a database, you end up with Microsoft SQL, or there are some options for it now, but it's basically some relational database, because that's where most people start. So did I, many, many years ago. But with neo4j, we don't talk about tables and structured data like that. We talk about nodes and relationships. So we talk about two different things that are way different from a database, but you have nodes, which has data, you have relationship between nodes, and the relationships can have data, and that's all the things you have in there. There's not a bunch of things like foreign keys and stuff like that. This is all we have. You have nodes and relationships, which is kind of nice. Very easy to work with. But let's get started with practical stuff as well. Getting started, installing it. How do you get started with this? Because I hate working on new tech where it takes 4 weeks to figure out how to get it installed on your machine, or it requires a bunch of other stuff, or the fact that if you're running on Windows, some things are really hard to get started at all because they're not meant to run on Windows, and if you're running on Mac, there are some things that are a problem there, and so on. Neo4j was interesting in that way because it took me literally 3 minutes to figure out how to run it. And then I could start working with my journey into neo4j. Because I want to have a local install. I want to have it on my machine because it makes it nice to work with. But an actual local install of actually installing neo4j on your machine is fine. It's built on Java. So it runs on Linux, Mac, Windows. That's fine. You can download it, you can install it. The problem is that when you download the installer and you click on it, it says, hey, you need to install the JDK, Java Development Kit. And if you're as old as me, you have seen this little pop-up way too many times to press yes to that. I do not want to have Java anywhere close to my machine for reasons. So I went that far and then basically went, oh, it needs a JDK, not doing that. Let's just back up. What's my other option? We can go to the cloud. Cloud is awesome. We really love cloud. I love cloud. And neo4j does come with a cloud feature. It's called AuraDB. Fully managed, you don't have to do anything, and if we go and look at the cost of it, it's very nice and easy. It's like, hey, sweet, 0 for free, which is what you need to get started. And then there's a very simple pricing model that I actually like. It's like $65 per gig per month is decent. I don't think that's a problem, and you've got enterprise as well if you need more. So that's kind of cool. Now, I didn't mention cost if you want to install it on your local machine. And the reason that I didn't do that is because if you go to that same page that I just showed you a screenshot from and you ask for the cost of running it installed on your local machine, it says Community Edition, free. Enterprise Edition, contact sales. That part there scares me. I still haven't gotten to that point where I had to contact sales because we run on Community Edition. It actually does what we need for now. But pricing is a bit complicated when you go on-prem. So if you are going to do neo4j, I would recommend looking at AuraDB to start with because it's a very simple way to get started and it has most of the things you need. So the cloud. I like the cloud. It made everything easy, but then once again, we all know that there is no cloud. It's somebody else's computer, so somebody has managed to install it. I still want to run it on my local machine because being in the cloud makes it hard for me to work on when I'm on airplanes. And this sounds like a weird thing as have a demand when I install code, but as recently as yesterday, I sat in my seat in the airplane writing code on my machine, and that wouldn't be possible if I was cloud connected, right? So it needs to be on my machine. So we're back into I need to run it locally, but I don't want to install it. So how do I go about doing that? Well, you have to choose one of two options. You can either go with Docker. That's where I started. I really enjoyed that. I have Docker on my machine. Most developers have today. You go and you write that little thing, Docker run, restart always, no, restart if not stopped or whatever it's called. Publish, you publish 2 ports and the name of the image is neo4j and then what version you want. You're good. You might want to go and add the auth and a persistent data volume as well. And that's it. It's up and running. There's nothing you need to do. And the nice thing with this is that when you do that, it actually, the first port, 7474, is a website. So if you browse to localhost 7474, you actually get what you would in SQL use the SQL Server Management Studio, SSMS it's called, right? So you can do your querying and your maintenance and everything as a web-based tool by just running the container, which is nice. I did that, that worked fine, and then I started looking, they actually have something called neo4j Desktop, and after seeing that, I switched over to that. Because neo4j Desktop is a little thing, it's a tool you install on your machine. So it's an application on your machine, and when you spin it up, you get this UI here, and you can run instances. So basically, it's an application with a window, like a UI app, but it also runs the database under the hood for you. It opens up all the ports needed and everything. So as long as this application is running, you can connect to it from your code. And whenever you want to play around in here and test out your queries and things like that, it's all built in. So inside of this tool that you get, that is your database as well, you get a browser where you can go in and write your queries and actually get your data out from your database in a nice way, not having to wait about 4 minutes to get SQL Server Management Studio up and running, because this is part of your database. You get a data importer. So if you need to get data into your neo4j instance, there's an importer tool that allows you to import things like CSVs and everything, and it's actually quite nice. You just give it a CSV and it tells you, oh, in this CSV, I actually found these different fields here. How do you want to map them? Do you want to have relationships and things like that? And the importer solves all that for you. And there is something called Bloom, which is for data analyst people to figure out how the data is related and everything like that. I have no idea how it works. I'm not a data scientist, so I don't use that part of it whatsoever. But there is a tool in there for you to do data analysis on top of your graph data as well. And it all comes out of that one tool. So let's have a look at what that looks like. So I have, nope, I did not want to go in that direction. Let's go there. I have that here in a non-dark mode because it's easier to read on a projector. So this is the tool that pops up. All you do is you start it, you open the application, you press a little play button here and it starts your instance. You can have multiple instances and every instance can have multiple databases. So in this case, I have one instance called test. I have 2 databases. The neo4j one you get by default. There's a system one. And if you want to create something to play around with, you just go, hey, I want to have a new database, let's call it neo4j. I'm not typing, am I? I just need to get into this thing as well. I'm going to call it neo4j, and it should be demo. Like that. And now I have a new neo4j database up and running. I can go into, say I want to connect and I want to query it. I come into this query interface. I can switch over and say I want to use the database that I just created. I get little guides in here, so we get some information about how to do it and things like that. But most of the important thing is up here where you can go and start writing your queries. So we can say match p, actually let's just do p, return hey, I'm going to explain what this means in a second, but basically if I run that, it's going to say, hey, there was nothing in the database, it's empty. Yeah, I just started it, so it's obviously going to be empty. But that is literally how hard it is for you to get started with neo4j. Download it, double-click the exe file, or do whatever you do on a Mac, and then you have a database and you can start playing. And now you can start running your queries and you can verify that your queries actually work the way that you want to. So getting started is ridiculously simple. Little caveat here that I want to mention is that I showed you how every instance in your local version could have multiple databases. That is an enterprise feature. If you're running the community version, you can only have one database per instance. So the neo4j desktop runs enterprise. It has all the features and all the bells and whistles, which you need to take into account if you then want to go and deploy it in production and you're going to run community in dev, test, or prod. Then you need to know that there are some limitations that will arise moving from the desktop version to the other versions. Now, it's possible to solve this very, very easily because you can run it as Docker containers. If you need multiple databases, you just run multiple containers and you're good to go. You just change the ports on them if they're on the same machine, and you're good to go. So let's go back to the primitives I was talking about, nodes and relationships, as opposed to tables and foreign keys that we have in our normal relational data. And I love the fact that they're called relational databases, but relationships are not really a thing. It's basically an ID here. It points to an ID there, and we verify that they are the same. Whereas in neo4j and graph databases, the relationship is a thing. It's a first-class citizen that is a thing, which I really enjoy. So on your nodes, you can have labels, which is like a limited set of tags. It's basically a key value pair thing, or in this case, it's more of it's a list in this case, an array of values basically. And you normally use labels for high-level things, like defining what type of node it is. I'm storing people in my database, so I have a label called person. I have a label called movie. I have a label called whatever I want. So basically labels is generally used for this high-level thing that we want to query. It's like, I want to get all the people living in this region, for example, or whatever. Then you go and say, I want a label. I probably want a label called person, because that's a type I'm going to work with. But your nodes can also have properties, like you'd expect. So you can add a key value pair store, and it's literally JSON. So you have a limited set of types you can use, but you can do whatever you want. It doesn't have the strict schema that you do in SQL. So you don't have to go and say, oh, now I'm going to create a new node type with this name, and it's going to have these properties. It's literally, it's a node. You can add whatever labels you want to it, and you can add whatever properties you want to it, and the system doesn't really care. You can add limitations, you can add constraints to it, but by default, it's like a document database. It's basically just JSON, right? And then you have your relationships. Every relationship has a name, and you can add your properties to your relationships as well. So you can add information on the relationship between things. So we're going to see the demo code I'm going to use, or sorry, the demo data I'm going to use is going to be movies and people, or actors. And if you have an actor as the first node, it's going to have the label actor. It's going to be acted in is the label of the relationship. And then you have a movie on the other side. And then on the acted in, we can add roles. We can have an array of what roles did this actor act in that movie, which makes it easier than in SQL, where you would have to have an actor table and a roles table and all of those mapping things in between, right? So, and here it is. Obviously, I had code for it. So that's the implementation that you will see. Person, movie, acted in, and there's limited information. It's like name, when they were born, and a few little things on the movie as well. So I mentioned that you have limited property types. What you can put into your properties is basically this. You can do string, bool, float, integer, point. It has a lot to do with graphical or geographical things, so points can be useful. Date, date time, time, and duration. And then you can do lists of all of these things as well, or arrays of them. One thing that is missing, it doesn't have a decimal. So if you're storing anything that needs exact precision, you will have to store that differently on your own and manage that, because float will not be good enough in most cases. But it's kind of sweet. And if we're going to look at like the relational database equivalent, labels would be your tables-ish. The only difference is that you can have multiple labels. So you can literally take your data and in theory then put it into multiple tables in your relational database. Nodes would be your rows because that's where you store your data, but instead of storing one row per with a lot of columns, it's one row and then there's a blob of data in there. Node properties will be your column values inside of your rows, and your relationships would kind of be your foreign keys, right? But foreign keys with a potential many-to-many, but they're always directed and they can have values on them as well, or properties on them as well. So you can do more with your relationships than you can with just foreign keys, unless you want to have a whole bunch of stuff you've built your own for your relationships. That's your query syntax. That's another thing I really like, because when you start talking to people about working with graph databases, I generally get the question, do I have to write Gremlin? Has anyone worked with Gremlin? Okay, Gremlin is a query language that, for example, Azure Cosmos DB uses. I have never used it for the simple reason that whenever anyone talks about Gremlin, they talk about how terrible it is and how they don't like it. The thing with this is that the query language is actually one of the things that sold me on using neo4j, because you query it as ASCII art. Say what? Yeah. If you imagine that the parentheses is a ball, so it's basically a node, right? And then there's an arrow in between, and then there's another ball or circle, which is another node. So if you can draw your thing that you want to be able to query, you take your drawing and you turn it into ASCII versions of your drawing of what you want to query, and that's the way you do your query. So in this case, we go and say, hey, get a person, it has a relationship to a movie, and return the person and the movie. And let's start with working with nodes, right? Because we're going to start with adding, reading, updating data as such, and that nodes is where we start because we need to have something to add relationships to. So finding nodes is what I just showed you when I set up new database. You do match parentheses n, which is basically saying, hey, can you find anything that matches this, which is basically, can you find any node? I have no filter on it or anything like that. Just find me any node in the database and then return that node. And what is the n? It's a variable. You can see it as a variable. So what we're saying is, hey, go and find any node, the parentheses syntax, and take each one of those nodes and put it into a variable called n. Then you can do queries on n, or filters, and then at the end you just go and say return n, which basically means return every single instance of that node you found. So it's fairly simple to work with, because once you know this, you can then go in and say, hey, return n.name, and just return that, or return n.name and n.description, so you get back name and description. You can do filters. So you can go in and say, hey, can you please get me all the nodes n where n has a label, and to define a label you do colon and label name. So I want to get any node that has the label person on it. And you can do, I want to get any node with the label person and actor on it, which is also another thing I like, that you can have multiple labels like that. So instead of having to have like a type variable or type property in your database or something like that, you can just go and say, hey, this is a person. That person happens to be an actor. That person is a director. And oh, by the way, that person over there is both an actor and a director. Let's just add the labels we need, and then we can query it based on that. And you can also do or, obviously. And you can use a shorthand syntax. That is what I will be writing, because I prefer that over where you just go match parentheses. I want to match a node, and I want you to verify that it has the label person, or I want to verify that it has the label person and actor, or the last one, give me all nodes that have the label either person or movie. Now the scary thing about doing person and movie, or movie in this case, basically means that you get back two different types of data. So when you then read the thing you get back, you then have to go and look at the node you got back and go and say, hey, does this node have label person? Then I have these properties to play with. Or is it a movie? Then I potentially have some other properties, unless they actually share a bunch of properties that you want to use. And finally, you can obviously match with properties as well. So you can filter on properties. You can do where, which is what I guess most of us are used to. You do match a thing and then where, like you do in SQL. Or you do the shorthand thing where you say, hey, match any node where, and then you do curly brace to say, this is the pattern that I want you to match. And in this case, I want you to match the name to Keanu Reeves, and then it gives me back just the Keanu Reeves node. And you can do multiple things. So you can map on labels and properties. So match any person node where name is Keanu Reeves, or map any person where person label and name is Keanu Reeves in this shorthand syntax. Now, the cool thing about this is once you learn this and you understand how to filter your nodes, this is all you need. Because you use the same thing to filter your relationships. And that's the only thing you need to know. You need to know how to filter relationships. You need to know how to filter nodes. You already know how to do it with nodes, and relationships are the same. Once you do that, you can then start doing things like return that node, or delete that relationship, or delete that other node I found, and things like that. So it makes querying really, really easy. Now, we're going to need some data for me to play around with. And if you want to, well, most of us do need to start with some form of data set, right? So we have some form of data that needs to go in there. And when you get to that, there is this flow chart, how you get data into neo4j. So is it semantic or app configuration, or is it just data? And then is it large volumes? Yes, no. Is it graph data for science, or is it a batch thingy or streaming and blah, blah, blah. Yeah, not doing that. I'm just going to not look at that thing and say, this is a demo, I'm going to do it very simple. But there are simple ways to do the import using tools. And honestly, in my application, we didn't have the data in the format that made sense to use any of these tools. So I actually just went and wrote a little console app. And querying SQL and turning it into neo4j inserts took me an hour to do, and we migrated all of our data. It wasn't a lot of data, but the tool was very simple, and the migration doesn't take a lot of time. So if this doesn't fit your build and you are actual developers, writing a little thing that does it for you with a little custom tool doesn't take very long. But I'm going to go with the movie graph, because one of the things I also like about neo4j is that they have a decent data set that you can just ask for. And the movie graph is one of the things that you can just go and say, hey, I want to have a graph of data that I can play with so that I can try out my queries. And it looks like that. So basically, it has two types of nodes. It has movies and it has people or person. And a person can follow a person, and a person can act in, can review, produce, write, or direct a movie. This is all you need. And this little graph here, there's actually a command in neo4j that once you've imported all of your data, you run a little visualization thing inside of your neo4j, and it comes out with this and says, here are all the different node labels that I found, and here is how they're connected. So you can actually take any of your data that you have today, put it in there, and it will show you how it's connected for you at the moment and what things belong together, which is nice. So let's go ahead and add the movie data stuff so we can query it. The podium is unfortunately very low, so I will be typing poorly because I can barely reach the keyboard. So when you come in here, there's this thing here saying try neo4j with the movie graph. If you click on that, it opens a little pane out here. You actually do end up here. But if it just explains what the movie graph is, you go in here, here is all the data, and all you have to do is either just run it, or you can press that thing and it gives you all of the Cypher data, or Cypher code. So if we go here, this is how it creates the data. So if you're curious about how they do it and things like that, this is the entire data set. And if we run that, it goes and inserts all the data that I need. That's it, that's all I needed. Let's go ahead and kill that window. So now there should be data in there, and I know that there's data because now all of a sudden on the left-hand side here we can see movie and person. These are the types of labels we find in our database. So I can click on those and I can pull out every movie in the database, and I can then click on these. I can obviously zoom and go around in here and play around with the data. And here are all the different relationships that was in there, and if I click on one of those, I get all the things that are using that relationship. So we can play around with the data quite nicely. I actually like the fact that I can take my data and visualize it in a graph instead of having to go to SQL and write a bunch of queries. Here I can just go and click around and expand nodes and stuff like that. So that means that we have data, and let's write a simple query. So we'll do match, which is I want to find something. So go ahead and find something, and I want to find a node. I'm going to add it to the variable p. I'm going to say that variable the thing that I'm looking for is going to be a person. So give me any node, which is a person node, or sorry, I call it person nodes. It actually means any node that has the label person, right? If that's more correct way to say it. Then I add a little arrow here to tell you that, hey, I want to have a relationship, and it should be directed in that from person to something else. And then at the other end, we can say, hey, can you please give me any movie where the title is The Matrix. And it is case sensitive, which is kind of annoying when you come from SQL, but that's just the way it is. And then we have to return something, so we return P. That is literally what I need to say, that please give me any person that has some form of relationship to the movie and give me that those people back. And we run this, and if we collapse this, we can zoom in and we can see we have Lily Wachowski, Lana Wachowski, Hugo Weaving, Emil Ephraim, who, if you know anything about Matrix, wasn't in the Matrix, because it's the guy who created neo4j. So he adds himself as a role in character in Matrix when you import this. But that's all you need. Like importing it, you write some SQL or some query stuff or some Cypher stuff. You run that, or you run the tool, and then once you've got that, you can start playing around with data and start querying. It's actually, yes, I am geeky, I know that, but it's actually the first time in a very long time I started a technology where I ended up just sitting with my laptop and writing stupid queries. Wonder if I can do this. Wonder if I can follow a graph and figure out how these are connected. What is the shortest path between Lana Wachowski and Ed Harris and all of that stuff? And all of a sudden you have a tiny data set, and all of a sudden it's fun to do with just a tiny data set anyway, because it's cool. So part of that Cypher I just showed you, it created a bunch of nodes. However, it did not use the create keyword, and I will explain why, but this is how you create a node by default. You go and say, create, parentheses, I want to create a node. It should have a label, person in this case, and these are the properties that I want to set, and that is basically the definition of my node, and when you run this, it adds that to the database. Now, annoying little thing here is that it always adds a new node, unless there is a constraint in the database that says any, and there is in the movie database, by the way, any node with the label person, there is a constraint in the system that says name has to be unique, and then this fails. But if it doesn't have that constraint, it will just add more and more and more, even if there is already a person in the database called Charlie Sheen. So create is not fantastic, because it will just always create a new one, and that might be what you want, but I find there's another way that's better. You can create multiple nodes with create. You just do one node and then comma and then one node, and you're good to go. You can create nodes with multiple labels, and you can add properties. So syntax-wise, it's always the same thing. There's no, whether or not it's a create or a match or a merge or whatever, the same syntax. This is what the thing I want to work with looks like. And then it has all of the things you'd expect from a query language, like, hey, order by name and skip and limit, so you only get 2 rows back and it skips the first 5, which, by the way, sounds like a really interesting way to do paging. It's a bit dangerous though, because skip and limit doesn't work on the nodes you're selecting. So when you do this query here, it would work because it's going to go one row comes back per person. But if you join in all of the movies, it will come in as for each person, there will be 1 row for each movie that person has made as well. So if you have one person with 4 movies, it becomes 4 rows. So when you do skip and limit, it looks at rows, not the initial node. So it doesn't actually go and say, I want to get the paged based on the first node. It goes, I want to go paged on rows, which can be complicated. It's fairly easy to rewrite it so you get it correctly, but just keep in mind that don't do that because it will bite you. Updating, once again, you use your match. This is the node that I want to find, and then you do set. Set n.birth year, set n.hair color, set n birth year equals null. If you do equals null, by the way, the property goes away, so it's not available at all. It disappears from the object in the future, so the property doesn't exist. It doesn't become a property with the value null. You can also do remove if you want to be more explicit, but it's literally the same thing as setting it to null. And setting labels, once again, same match, and then you do set, and then you use colon, what label you want. And if you want to remove it, you do n colon whatever you want, or colon and your label name, and you're good to go. Once again, same syntax. Updating is a bit more interesting. So here you get a combination. So you match this person here, so you get key entries to the database, but then you can do, instead of doing multiple sets, you can actually go and create a new node down here with all the things that you want it to look like, and then you do what's called a merge, and it will take this here and it will basically merge that on top of it. So if there's already a birth year on the person, then it will be overwritten. If it's not there, it will be added. So it's a nice way of doing multiple updates without set stuff after each other like that. And merge I like because it also has the ability to do on create and on match. So in this case here, it will always just do it. But if you do merge on create and use this syntax instead, you can go and say, hey, if you didn't find it in the database, I want you to do this. If you did find it in the database, I want you to do that, which means that updating things like modified fields and created fields is really nice because you can set created here and updated there, but it's still the same query. So you don't have to go, is it an update or is it blah, blah, blah. It's just one query and it fixes it for you. So that's nodes. But nodes are pretty useless if you don't have relationships or paths going through your system. So that's where you come in with that new other syntax where you define a path, which is a node, a relationship, and a node at its minimum. But a path can also be a node and any number of relationships and nodes along the way until a final node. So every path always starts and ends with a node, but there's an infinite number of nodes in between if you want to. Querying it, I showed you before, you add that little arrow thing. Now it's important to note that it is dash arrow or dash greater than. The reason for that is that when you want to query a specific thing, you add little brackets. Once again, if you look at the ASCII part of it, the little brackets kind of look like the label you would put on top of your little arrow, right? To tell it what it is. So to match any person that acted in the movie The Matrix, you write, hey, get me people or person where there's a relationship called acted in pointing towards a movie, and the movie should have the title The Matrix. That gives me everybody in The Matrix. You can also turn it around if you want to search. This is exactly the same query. The only difference between these two is I want to show you that you have a direction of your relationship. Every relationship is always directional. If you want to have a bi-directional relationship, you need to set up two relationships. So you have both of them going both. But it also means that if you had them going both ways, if you then go and search with that syntax, where you say, hey, I want a relationship, but I don't want a direction, you then get both of those relationships back. So you can add the arrow if you want to define the direction, or you can go and say, hey, I don't care about direction, just give me everything. So this will take any person that has any relationship with any movie. So in this case, it would get me anyone who's both acted in and directed a movie, because I don't care about the direction. Now, in this here, I put P and M as my variables for the different things, and I return those. You can also go and say P equals the whole thing. P is stupid to use up there because I use it. Anyway, P in this case then becomes a path. So when you do return P here, it actually returns the entire path, not just the instance objects where it goes here is the person, here's the movie. This will give me back the person and the relationship and the movie. So I can then traverse that as I want. And that is very, very powerful. And then you can take that thing here and add to it and say, hey, I want to have I don't care about directions, but I want to get any person who has acted in or directed by a relationship between person and movie, and that would give me the entire path back. And then you can go and match more relationships, and you get queries like this, which is very readable, right? It's actually very readable when you break it apart. We have the match that we're used to, get any person called Charlie Sheen. I want to see who Charlie Sheen acted in, or what movie he acted in. Then I want to take that movie, and then I want to follow it inverse relationship to get any person who has directed the movies that he was in. And then I want to return the movie title and the director name, and that way I can very easily get all the directors and movies that Charlie Sheen was involved in. And when you draw it out, it becomes that. So this thing here, it's extra hard to read because it's on a PowerPoint slide and I had to do row breaks. But if you just look at the little ASCII kind of idea of it there, it kind of makes sense, right? And creating relationships, once again, you can do your create. So you can do create, this is my node, this is the relationship I want, this is the node. I wouldn't recommend doing this because yes, it creates a node, it looks at the relationship, and it creates a movie. Now it literally creates all of these things. So if you run that command, it goes and creates a complete new set of nodes and relationships. So if you have to set up a few of these relationships, you're going to end up with multiple Charlie Sheens or whatever because it creates one instance for each. Instead, what you want to do is you can go and say, hey, match that thing. So you find Charlie Sheen in the system, and then go and find the movie that you want, and then you go and create, and you then, it knows the nodes, and then it just creates the relationship in between. But once again, it always creates. So if you do create, it will add another relationship and another relationship potentially. So what you want to go with is, once again, merge. Merge, it's like, I've never more or less used create at all. I merge everything because it handles update and create in the same way. So here you go merge, you go find that node, and then I want you to merge it into this thing here. So if there is no acted in between them, add it. If there is already one, then don't do anything because it's already there. So how can we query paths and, add and query paths and relationships? So I'm going to go and figure out where I want to go. I'm going to go here. We're going to go over to neo4j. I'm going to start off by adding myself to the database. So I'm going to go merge. So as I said, I was merge. I'm going to be a person. So I have the person label. I'm going to have a name. The things that drop down are decent, but they're actually not correct. They won't give you the correct properties all the time, so you still need to know what you're typing, but that's fine. So we go name, Chris Klug, like that. Let's do capital K. And if I run this, it will say one node created, one property added, one label added, and then if I run it again, nothing happens because it's a merge, so it only runs once, right? So that's kind of nice, and if I want to look at it, I just go and say match, and we basically match it on the same thing. So let's take that. Whoops, that wasn't at all what I wanted. Not being able to reach my keyboard is not helpful. Let's type it up manually. So we'll do P person name Chris Klug. That didn't come out right either. And then return P just to find that I'm in there. And if we run that, I'm here and there's the properties on me. So that's in there as we expected. Now I did forget to set the born property because all persons are supposed, or people are supposed to have a born. So let's go ahead and take this. We'll just replace this with a merge. And then I'll go ahead and I'll merge a person with the name Chris. And then we're going to go down here and say set p.born equals, and now you're going to see exactly how old I am. Set that, run it, one property set. So that looks fine. And just to verify that I'm in there, we can just go back to my match again, and we can see that I'm in there and I now have a birth year, right, as expected. Now, if I want to add myself as an actor to the matrix, because I've always wanted to be in the matrix, we'll do match. So I'll do top duplicate matches in here. So we'll do match, and I want to find a movie with the title The Matrix, like that. And then we'll do another merge. And in this case, I want to merge the person, P, and I want to merge it using a label, if I can type the right thing, called acted in. Acted in, there it is. And then we want to merge that with M, the movie. We run that. It's going to say create a one relationship. And if we go ahead and we do that same query that I had down here that finds any person, but we'll go for let's go for acted in this case. Lots of complicated characters to write on a Swedish keyboard. There we go. We find all the actors in the matrix, and we try to make this readable on this tiny resolution. We should be able to, there I am, Chris, Klug, and we still have Hugo and Lawrence and Carrie Ann and all of my friends that acted in the movie with me. So that relationship seems to have worked. Now, a thing here, actually, I could have given myself a role, but let's ignore that. One thing to keep in mind here, and you get this information very, very quickly when you start looking into neo4j in the documentation, is query performance can be complicated. So it's a little bit weirder to do queries than it is in SQL, because even if you can put indexes into your columns, it will only use one index. It will only use an index for the first node that it finds. So in this case, it's very likely that it will say that, hey, you are asking for a movie and you have put a filter on the movie. So I'm probably going to start in that end for your query, because that is very likely going to be the least number of nodes that it finds. Then once it has found that, there are no more indexes and stuff involved. Instead, it takes that node and then it says, hey, can you give me all of your relationships called acted in? And then I want to get the nodes at the other end. Then it goes and finds all of those nodes and so on. So it basically goes a depth-first traversal through your entire thing from your first anchor node, which means that you have to think about how you write your queries a bit more than you might do normally. Now, what is nice is that you can go into neo4j. I'm just going to make a little change here to make it a little less performant, to show you some differences. So I'm going to remove the label here and say, hey, any node that has the title of the matrix, and then go find acted in and all of that. And if we do explain here, we run that. Actually, let's close this down. We now get to see kind of what you see in SQL as well when you do a query plan, so you can see what it actually does. And it basically goes here and says, hey, I want to do a full node scan of every node, and I'm going to come up with 172 rows. Then I'm going to go and filter those nodes, and that's going to give me estimated 9 rows. And then I'm going to expand all of the relationships, another 9 rows. And then it's going to go and find all of the nodes there. And then once I've gotten to that point, I can go ahead and produce a result and return it back. And you can get information here about how many rows it expects to come out and things like that. And if we change this query and we go and make it a little bit smarter and say, hey, how about we know that this thing here is a movie, like that, and we run the same thing again, it is now smart enough to go and say, hey, I can use a unique query that's on the name of the movie, and I get 1 row, and then that turns into 5 rows when I expand acted in, and then I get my people and so on, and I can get that information. So now I know that this is a much better query. And on top of that, you can go ahead and say, hey, explain is literally just a query plan. This is what I think is going to happen. If you go and say profile instead, it actually runs your query and gives you everything back. And if you run that, you can then go in, and this is going to be hard to see, but if we zoom into this, it actually goes in and says exactly how many bytes of memory it uses, how many page cache hits it does, and estimated number of rows, and how many times it goes through database and all of that stuff. So you can now start tweaking your queries. And honestly, according to Neo, they should be looking at tweaking, or you should be looking at not just tweaking your queries, but actually store your data in your database in a way that corresponds to your biggest bulk of queries, so that they are cheap, and then maybe you need to do more complicated stuff for the lesser used queries. So look at your data storage based on how you query it, not based on how your relational mind would do a table with foreign keys, right? Hard thing to figure out in the beginning. I still work a bit with that, and so far we haven't found too many problems with what we've got, but it might happen. And running the plans is kind of fun, because once in a while you go, oh, I didn't think about that, and then a little tweak can make a huge difference. Now let's go back in here again. Removing data is kind of the same thing as adding it, very similarly. So once again, you do your match. You get whatever you want to play with into a variable, in this case P, and then you go delete P. That's it. This will delete the node with the label person and the name Charlie Sheen. Now, this will actually break if there's a relationship. So if there's a relationship to it, it will fail in the same way that SQL won't allow you to remove something that has a foreign key on it. So what you do is you do detach delete, which says, hey, delete this node, but also any relationship, incoming or outgoing, remove those as well. So we can delete the node without having any relationships, which is nice. Also a lot easier to do than in SQL, because in SQL you have to start traversing stuff, which is annoying. You can also do that. Match n, detach, delete n, which literally takes every node in your database and deletes it, and all relationships to those nodes as well. So this is kind of going RMRF on your entire database. It's nuked and gone, and there is not a single warning when you run that command. In SQL, you're at least locked into only nuking one table at a time in most cases. This nukes your entire database, and it's fast. It's really good when you're in a dev environment, when stuff isn't really aligning. You just do run that, and you import the data again. Very, very smooth. Deleting relationships is also very nice. Same thing. You do your path, your match, and you give the variable, you assign your relationship to the variable, and then you do delete R, and then it deletes that relationship. You can also delete any relationship by basically saying, hey, get Charlie Sheen with any relationship to any node, and then delete R, and that will remove that. So as long as you figure out how to write these basic filters or matches, you're good to go with all of the create and delete and the update and everything, because they all work the same way. So removing data, well, I'm just going to quickly remove me and Emil from the database. So if I wanted to remove me and Emil from the database, I would write something like this. Let's start out with match, p, person. We'll go straight for, actually, let's do that. Then we go for acted in, because I know that both me and Emil acted in the movie called title The Matrix, like that. This will give me everything, and if we have and then we need a return p. So this will give me all of the people in the matrix. We've got me and Emil there. So we go in here and we say, hey, I actually do want to do a where p.name equals Chris Klug, or p.name equals, actually it's just one equal character, not C#. Emil, like that. That should give me and Emil. There we are. And then to delete those, we basically just, if we want to remove them from the database, from the relationship to begin with, we can go and say, hey, give me the relationship, and we can do delete R. If we run this, it removes two relationships. If I go and ask for the people again, we go like that. It's going to be nothing because I'm not in neo4j or in that movie anymore. But if I were to go like this, we can go and see that we are still in the database. And finally, I can go and say, if I want to remove these, we can just do delete p. And if I did want to go and delete us to begin with, I could much easier just go and detach delete p, and it would have removed the relationship as well. But the syntax, once again, I like it because it's the same match, it's the same thing, just assign it to a variable and tell the system what you want to do with that variable. I've deleted. Yep, that's good. Now, there are a few more things to go through. I've got about 10 minutes. This is going to be close. I'm going to go faster a little bit to get through it all. Traversing the graph is where it gets cool, because now we can go and ask multiple levels out. We don't just go node, relationship, node. In this case, I want to find all the actors that have ever worked with Keanu Reeves. So this is kind of nice. All I do is I say, here's the match that I want. I want to get the person, and I want to get the person that he acted with. So those are the two ends that I want. And the way that I want to connect this is acted in, and I want to do it 2 times. So basically, the first acted in is going to be from Keanu Reeves to the movie he acted in, and the second acted in is going to be from that movie to the other person, the other people who acted in that movie, and that would give me all his co-actors. You can also go, once you have that, you can then go ahead and use a return in here with using 2 methods called helper, like little functions in there called nodes and relationships, where you can then go in and say, because we are going to get, in this case, the whole path. I'm not asking for just the co-actors, I'm actually asking for the whole path because I want to get the roles that they had as well. So what we can do is say, hey, for this path, go and get all the nodes, get the first node in that array and get the name, and that's going to be the actor, and then take the relationships for this path and take the first relationship and the roles on that relationship and put that out as role, and basically it allows us to traverse the thing so that it ends up saying, this is going to be Keanu Reeves and the roles that he had in that movie where he acted with that person who had these roles in one ginormous query that's fairly easy to read, right? But the really cool thing is shortest path, because this is where I wish I had a better data set, because you can go and you do your path, like your match, like you normally would. So this is the person and this is the person that I want to match. So basically, shortest way from Keanu Reeves to Tom Hanks, and I really don't care about what type of relationships you use, as long as there is some form of somebody knows somebody that knows somebody. So basically, if Keanu Reeves needs to talk to Tom Hanks, what is his fastest way to find a direct link to him? And by adding plus, I allow as many relationships as possible, or as needed, and I want to get the shortest one. And you can also add logic in there to say, I also want to weight it. So if you know that the relationship has like a cost or a time or a distance, I can then go and say, find the ones, but make it shortest based on shortest time of travel, for example, or cheapest tickets or whatever along the way. And when you run that, you end up with this, in this case, because I asked for shortest one. So Tom Hanks to that thing you do, to Charlize Theron, to the Devil's Advocate, to Keanu Reeves. But if we go and make it shortest 3, I get 3 options. And then it actually gives me the same one idea. No, in this case, it goes Keanu Reeves, The Matrix Reloaded, Hugo Weaving, Cloud Atlas, Tom Hanks. Or it goes through The Matrix to Hugo Weaving, or it goes through The Devil's Advocate and Charlize Theron, so like that. So these kind of searches that can be arbitrarily long is really, really hard to do in SQL, but really, really simple to do in neo4j or a graph database. So this is where I'm going to see if I can write some code. So I have this little tiny application. I actually think it's up and running. It looks like this. So you select the person you want to go from and the person you want to go to, and you press submit, and it shows you the different paths going back and forth. And now there's only me and there's only one movie that I made up, and that's because I haven't built it yet. And the code looks like this. So the only thing we really care about is on get and on post. On get, I need to go and get all the people in the database. And the way that we do that is, well, first of all, we need to go in and say, I want a NuGet package. So we're going to do manage NuGet packages. I'm going to install neo4j driver. The syntax for talking to neo4j is a little bit different than SQL, but you get used to it quite quickly. Once we have the driver, we can go, I need some configurations. So we're going to go and say configuration config to get that injected. Once I have the config, I need to go to app settings and I need to populate this. Where can I find the database? Well, if we go back here and we look to local instances, there's a connection URI here. So I take that, paste that in here. What database do I want to talk to? It's called neo4j demo. What user? It's going to be neo4j because the user is hard-coded. And then this is going to be my very secret password, like that. So now I have my configuration in here. Now to create the driver, the thing that talks to database, N4J, why is this not popping up? This is scaring me now. There it is. I create a driver like that by saying graph database.driver. It's going to be async task. Inside here, I need to say, here is the configuration, here is the URI, and here is the username and password to talk to it. That's kind of all I need to create my driver. Once I have my driver, I can write my query. So we'll do var people result. I wish I had a little thing for this, so I didn't have to see me type this, but let's try this. Await driver dot executable query. I'm going to write my query in here, and then on my new line, I'm going to say, because I'm using a separate database, I actually need to go and say, hey, there is a query config, and the database name for the database that I want to talk to is going to be config neo4j database. That looks correct. Then we go and say execute async like that. The query that I want to run, well, it's going to look like this. So we'll do at, move in a little bit, we say match p person. This is all I need. I need person, and then we do return p.name as, and it needs to be, I need to be capital N, so I'm doing as name, and then order by p name like that. That should give me all the people. Once I have the result back here, I can go ahead and change my people here into people result dot select, and then inside of our select we say for each one of these rows I want to go and say x dot let's try this again, x dot as why are things flopping around, and can you, okay, let's try it again, as object. And then I can, or it has built in sort of very simple mapping logic that allows me to go and say, hey, map that to array. Why is this complaining as? Oh, okay, I'm missing an import. There we go. And it basically maps it to a little class here called person. And the reason I did it with capital case N is because it's case sensitive. Once I have that in place, it will now get all of my people and put them in my list. The next thing I want to do is on post is basically figure out how to, what are the relationships, what are the paths that I can find based on this. So I'll start off by saying, I'm going to create a driver once again. It's going to be async task. Then down here, we go and say, we add our query. I'm going to show you the query, but it's basically the same thing as I did before. And then the query, well, I generally like to go over here and try out my queries. So I'm going to go over to my query tool here, and I'm going to write a little query, and it's unfortunately not that little. So let's try this and see if I can type that in the last 2 minutes. Let's do shortest, and let's pull out 5. And we're going to do actually match p equals shortest 5. And I want to go from person, and let's try, for this case, we'll try Tom Hanks. And I want to go through any relationship that is acted in or directed, and then I want to find another person, and it's going to be, in this case, name Keanu Reeves, like that. And we do return p. What? Oh, thank you. Look at that. Note. What did I miss here? Oh, that's not supposed to be it. It needs to be start. I want you to follow along as far as you want. Here are the roles. That looks good. So that query looks like what we want. Let's go back here. Let's just paste that query in here. Hard code in Tom Hanks and Keanu Reeves is a bad idea. So let's go and add a couple of variables in here. We're going to say from. We're going to name this 2. And then we need to add a couple of parameters. So we do, nope, there. With parameters, and I'm just going to do this syntax for that. So we're going to do 2 is going to be 2, and from is going to be from. So to and from are just properties that I have from when you post them back from the front end. And then I need to do a little query majig thing here to get this to work. So what we're going to do is, N4j, this is not very important, it just needs to be there. It uses this parse path method that looks like this, which is, all the code is going to be available for you afterwards if you want to look, but it basically, it goes through the path and figures out what movies and what people are along the way and turns them into something that I can render nicely on screen. Now if I take that and I press something useful like that, and I have sacrificed the right thing to the demo gods. We could go from Anthony Edwards, who I have no idea, to Carrie-Anne Moss, who I actually know who it is, and we do submit. And here are all the things where you can find that they're connected. So you can go from Anthony Edwards to Top Gun to Tom Cruise to Few Good Men to Jack Nicholson to Something Gotta Give to Keanu Reeves to The Matrix to Carrie-Anne Moss. And that takes almost no time to write whatsoever. There is a bug in here that's fixed in the code that you're going to see, because if you were to go and say Tom Hanks and you say Ed Harris, I want to highlight this. I know that there's a bug in the code right now. You get Tom Hanks to that thing you do to Tom Hanks to Apollo 13 to Ed Harris, which is kind of stupid. So you actually have to write a little bit of extra code to go and say remove everything that has duplicate same nodes multiple times. So you don't want to go Tom Hanks to Tom Hanks. You want to go Tom Hanks, Apollo 13 to Ed Harris without, which you already have. So that should go away. But that's kind of the way that we interact with it using C#. It's fairly easy to work with, fairly easy. I actually think it's really easy. What comes up as a bit complicated is that it doesn't have all the bells and whistles you get from Entity Framework in the way of transaction boundaries and handling unit of work and all of that stuff. You have to build that on your own. There is still transaction work in there, but it's very small. So you do a thing, and that command runs in a transaction. And then you do another thing that runs in a transaction, but you can't really go and say, I want to have a transaction around everything at the moment. Quickly, just things to think about. Constraints. There are constraints in the system, so you can go and say they need to be unique, they have to exist, they have to be of this type, they're a key. But if you're not running the enterprise version, you're only allowed to use that one. So stick with that one if you're doing community stuff. Modeling concerns, you can think about what is the thing that you're going to start querying. How do you narrow down the starting point as much as possible so that your depth searches afterwards become as few as possible? And that's really, really important. You have to think about how you do if you want to do it as a label or as a property. Labels are auto-indexed. You can add indexes to properties as well, but labels are easy to search. And they generally work well for things like categories or types and things like that. You can also think about labels versus relationships. Do you really need relationships like you do in relational stuff where you want to point a thing where a label might be good enough, right? So sometimes labels are better than relationships as well. Like I said, optimize for your queries and use profile and explain to see how your queries perform. I have a little mini thing that we'll skip, but it's basically there's a little command you can run that takes all of the data and turns it into what I showed you before with the node types or labels and how they connect to each other, which can be really useful when you have a big data set. You can just run that and it says this is the way that the system connects. Thank you all for listening. I'm sorry I'm 2 minutes over. All of the code is available on that bit.ly link there, either the QR code or that thing up there. I'm old and middle-aged white dude, so I'm on X. Sorry. I'm also on LinkedIn if you have any questions, and I will be around on and off for the rest of the conference. So if you have any questions, feel free to come by and ask, and I'll be happy to show you and tell you some stories. Thank you so much.